First unit is talking about exponent laws and logarithms. So our first lesson is exponents and exponent laws, the review. So the first thing you need to know is what the heck is a power. A power is a base and an exponent together. Your bases can be variables, and so can the exponents be variables. Now we need to remember how to change forms back and forth, and that's where we get into our exponent law review. So our first review we have up on the top here, we have the multiplying law. Our multiplying law says when you're multiplying bases, and things are sitting side by side, they mean they're multiplying. So when they're multiplying, you're not going to always see a multiply sign or brackets. Sitting side by side means they're multiplying, and that's good enough. So if you have the same base and you're multiplying, you will add their exponents. Another example for that is this example here. If I've got 5 squared times 5 cubed, I'm going to take those guys and add them to give me 5 exponent 5. Okay, that's our multiplication law. Same base, add the exponents. We can take a look at the division property. This law here says if you're dividing with the same base, you subtract their exponents. Here my base is the letter A, same base, subtract your exponents. And an example of that could be 2 to the 7th power divided by 2 to the 4th power, and that's going to give me, when I take 7 and 4 and subtract them, that's going to give me 2 cubed. Okay. Our next power is called power of a power law. Power of a power law is this law right here. And what it talks about is if you've got a bracket and an exponent on the outside of brackets, the exponent on the outside of brackets multiplies in to the exponent in the inside, not to the actual base, but to the exponent on the base. So that's why they're sitting side by side, because again, if they're variables, side by side means multiply. An example of this, if I've got 2 to the 3rd power, so 2 cubed, all to the 4th power, I would take the 3 and the 4, and now I'm going to multiply them. That's going to give me 2 to the 12th power. That is our multiplying rule. We also have the multiplying rule up here, where we've got more than one base in the brackets. If you have more than one base in the brackets, the variable or the exponent outside gets multiplied to each base inside. If you take a look, those bases, they look immediately like they do not have an exponent, but they do. It's a hiding number 1. So there's a hiding 1 on the A and on the B. So when we multiply that through, we get A exponent n, B exponent n, different bases, so I cannot add the n and the n. Okay? If they were the same base, I could add them. Now let's take a look at an actual example of questions like that. If I've got 2 times 3 exponent 4, that's going to give me 2 to the 4th power times 3 to the 4th power. I could also use variables. I could say I've got x cubed y squared all to the 4th power, which will give me x to the 12th power, y to the 8th power, and I would be done. That is fully simplified. Okay, you just multiply the outside exponent inside the brackets, only to the exponents. Okay, we're going to take now a look at the division property again. Division property in brackets now. You've got 2 different bases. Same rule applies. The exponent outside goes to every exponent inside. I have a hiding 1 on my A and a hiding 1 on my B, which is why they get the n. So if I give you an example, we have x to the 4th power over y to the 6th power, all cubed. That is going to give me, when I multiply, I need to multiply the 3 to the 4, and I need to multiply the 3 to the 6. That's going to give me x to the 12th power over y to the 18th power, and you would be done there. Okay, any questions so far? Pretty good review. Does it ring a bell from before? If not, hopefully you're kind of getting this stuff. We can now take a look at the bottom properties. I've got A exponent 1 is equal just to A. They're just showing you that any variable or any number, any digit, any value has a hiding exponent 1. Do you have to show the hiding exponent 1? No, it typically hides. It's showing you that they are equivalent. This one is showing us the A exponent 0 is equal to 1, meaning anything exponent to 0 equals 1. The base and 0 exponent disappear completely, and they are replaced by the value of a digit 1. So another example for that. We have an example. I could have 7x all to the 0. That's going to give me a value of 1. If I have 7 times x to the 0, that's going to be 7 times 1, which gives me 7. Okay, so the 0 exponent is the part that gets replaced by the value digit 1. So right here, this is the only part replaced by the value digit 1. The brackets here are telling me that the 0 goes to both numbers or both values in the bracket, which is why the whole bracket is be given the answer of a 1. Okay, any confusion so far on the value of 1? 0 exponents? Okay, now we're going to take a look at the last two properties. We've got negative exponents and we've got radical exponents, fraction exponents. So if we take a look at those ones, I'll take a look at the negative exponents right here. They're telling me that b cannot equal 0 on the bottom here. That one is, it's called a boundary or a restriction on your variable. Restrictions tell us what is not allowed to happen. So this is saying that on the bottom of any fraction, you can never have a 0. Ever, ever, ever. So if you take any digit and divide by 0, your calculator is going to tell you error, can't be done. And your calculator is smart enough to say can't divide by 0. Okay? So you cannot divide by 0, so the bottom number can never be a 0. Your base typically can never be a 0 as well. You can have a 0 for an exponent, but not a base. So this is showing us that any original digit, I can put any variable or digit into a fraction form by putting in a 1 underneath it. So this is the same as me saying b exponent negative m over 1. And what have they actually done to this? This is in fraction form now. What they've done is they've flipped it top to bottom. And the rule is when they flip it, the negative exponent now becomes positive when it's in the opposite position it started from. So it started on top as a negative, it goes down to the bottom as a positive. Now if we've got different variables that are positive and negative in different parts, the same thing applies. Here's an example. If I've got w to the 5, y to the negative 3 over x squared and z to the negative 4, I've got two negative exponents there. The two negative exponents I have are going to switch places. The y negative 3 is going to go to the bottom to visit the x squared, who's already positive on the bottom. And this z negative 4 is going to go to the top to visit the w5, and they're going to sit side by side. That gets rid of their negative exponents. So the final answer will be written, the w and the x do not change places because they are already positive where they're starting. You want to get rid of negative exponents, you want them positive always. So your final answer is going to look like w exponent 5, z exponent positive 4 on top. On the bottom, you're going to have x squared, who originally started there, and now the y cubed comes down. The z and the 4 have now been changed to positive exponents by switching places from where they started. Okay? Any questions about the negative exponent law? Once you start working with it, it's going to get a lot easier. Okay, we're going to move down to the rational exponents. So here we've got rational exponents or fraction exponents. Whenever we have a fraction exponent, we can turn it into a radical any which way and any time. What we do is the fraction itself as the exponent, each of those digits have a special place they belong in a radical. The bottom number of a fraction is going to become the index. The top number of the fraction in the exponent form, this guy stays as the exponent on the base. It stays as the exponent on the base in the radical. So another example of this, I could have 5 to the 2/3, and that's going to look like cube root 5 squared. The 3 becomes my index. The 2 stays as the exponent on the 5. Any questions so far? We can also have variable exponents and variable bases, which we often do with log laws that are coming up in lesson 1.4. Any questions? Okay, we're going to go through and do a couple examples now on the next pages. All right, bottom of your page. It says, use the exponent laws to simplify, then evaluate. Evaluate means solve and find an actual answer. So if I've got 3 exponent 4 times 3 exponent 2, what I'm looking for is the same base. Is my large number the same? Yes, it is. Then I can use the multiplying rule, which means add my exponents. This will simplify to 3 exponent 6, and that's going to give me an answer of, I'm not sure, anybody got 3 exponent 6 on their calculator going? 729, perfect. Okay. 729. Now, if we take a look at letter B, the brackets are serving a purpose. The brackets' purpose is to tell us that our base is a negative digit. So I've got a -2 for a base. So since my base is the same top and bottom, I'm going to take the exponents and subtract them. So now I'm going to end up with a final answer of -2. Yes, it's still in brackets because he is the base. Now to the exponent 3, so cubed. The 5 and the 2, I subtract them. And now we know that -2 to the cubed power, if you want, you can throw it in your calculator. All that tells us is it's -2 times -2 times -2. We have an odd number of negative signs, so you're going to have a negative answer automatically. That's going to give us -8. Letter C, I've got a exponent 4 all cubed. What that's telling me to do, since I have a bracket, is to take the outside exponent and multiply it to the inside exponent. My base will stay as a, and my exponent now becomes a 12. Remember, you're not adding exponents there, you are multiplying them. Now, another way to remember how to do that question, it seriously is only the multiplication rule. I could write that out as expanded form. The outside exponent has a job. It's telling me how many of the bases I actually have. So this is telling me I have 3 sets of a to the exponent 4. So I've got a exponent 4, a exponent 4, a exponent 4. 3 sets being multiplied. So if I use my multiply rule like over here, I would add my exponents. If I add all my 4s, I get the 12, which I originally get when I multiply them. Okay? So it can be expanded and added exponents as well. So 2 ways to solve. If we take a look at letter D. Am I going too fast for anybody? If I am, please ask me to slow down, okay? I do tend to talk fast. Okay, on letter D, one thing we have to remember is that every single thing in brackets will have a hiding exponent 1. And usually everybody remembers the variables to get the exponent, but they forget the coefficient digits. The 3 here also has an exponent 1 as long as with the p and the q. That means the 4 is multiplying to all 3 of them. So I will end up with a -3 exponent 4. I will have a p exponent 4 and a q exponent 4. Now, since this 3 is negative in brackets, I need to keep the 3 as in brackets negative. How come? Because if I write 4 sets of this, that's going to give me 4 negative signs. 4 negative signs means I will have a positive answer. In order for me to get a positive answer here, I need to keep the brackets. If I don't keep the brackets, I have a floater negative, which will make my answer here a negative. And my answer is not a negative here, it is a positive. So 3 exponent 4 is going to give me 81. So it's going to be a positive 81. And my p to the 4th power, q to the 4th power, they sit side by side, cuddled up to the 81. The 81 is now considered the coefficient. Letter E is a bit more complicated. We've got a couple brackets, but we've got a couple exponent laws going on. Before I can combine the left bracket to the right bracket, I need to realize the 2 on the outside of brackets needs to multiply into my whole bracket. So I'm going to have 5 exponent 1 and a exponent 1. that also get multiplied by the 2. So I'm going to have 5 squared, a exponent 2, b exponent 12, all timesing by 4, a exponent 2, b exponent 1. Do I have to show the 1 on the b? No, but it's a good idea to show it so you don't forget to add it when you combine them now. Now we have to combine them and simplify. This dot or the brackets here would mean they're multiplying. Since you're multiplying, you have to add the exponents on the things that are identical. So the ones that have the letter A, you add their exponents. The letter B, you add their exponents and combine them. The coefficient digits, you actually do the multiplying and you multiply the digits. So it's a two-stepper. If I take the digits, I multiply them. 5 squared is going to become 25. So I have 25 times 4 when I take my coefficients. 20 times 5 times 4 is 100. So I know my answer starts with a coefficient of 100. Now I take my letter A's and I look at my A's. I've got a 2 and a 2. That means I can add both my 2 and my 2 on the A because the base is the same. And I'm multiplying, so I add the exponents. I get A exponent 4. To combine my B's, I'm going to add my B's same way. I add their exponents. I'm going to take 12 and add it to the 1 on the B. And I'm going to get B exponent 13. This would be my very final answer. That is fully simplified. You cannot go any further unless they tell you what A and B equal. Any questions on those so far? Did I lose you anywhere? No? Okay. Now we're going to do letter F. Letter F is a bit of a stinker. It looks a bit more complicated. First thing I want to see is if I can solve inside brackets first. If I can solve inside the brackets first, because of bedmass, I do that. Bedmass means brackets before the outside exponent comes into play. So I'm going to solve my brackets first. If it means multiplying, all I have to do is write these guys side by side, and I will multiply the 4 and 3 together. So this one's going to look like this. These two multiply, I will get a 12 on top. It's still in brackets, and the 4 is still outside. Now I take my x's and y's, they're different, so I can't do anything with them except for stick them side by side. So y cubed x to the 6. On the bottom now, I've got a 6 as a coefficient, and I've got an x exponent 5. Am I finished inside the brackets? No. You can still simplify more inside the brackets. How come? I can divide the digits evenly without getting a decimal, and I can also subtract the x's. The y's I have nothing to do with, they have to just sit there side by side. So now I'm going to take the 12 and divide by the 6. The answer is 2. It will go on the top. So I'm going to have a 2. The y cubed stays with him. And now on the top, I take a look. I've got x6 and I have an x5 on the bottom. When they're being divided, same base, you subtract. 6 subtract 5 means I have 1 x left. So I'll have x to the 1. Now that is all still in brackets with a 4 outside, saying, and now I've got 4 sets of those. So now I need to multiply this 4 into every bracket, or to every exponent inside the brackets. There's a hiding 1 on my 2. I'm going to multiply the 4 into every exponent now. So the 2 gets the exponent 4, the y gets the exponent 4, and so does the x. So I'm going to have 2 now exponent 4, y exponent 12, x exponent 4. In your final answer, they will typically write the variables alphabetically. So you can switch x and y positions, that's fine. And you will also simplify 2 exponent 4. 2 exponent 4 gives us a 16. So our final answer will be 16, x exponent 4, y exponent 12. We cannot go any farther, we're done. Any questions so far? Okay, example 2, we're going to now combine exponent laws and have more than one thing going on at a time. If I take a look at A, the only thing that's going on again is multiplying property, so I add exponents. I'm going to take my 5 and my 3, and I'm going to add them, and I'm going to multiply the coefficients. So, multiply my coefficients, I get an 8, my base is x, and now I have 5 plus 3 gives me exponent 8 on my x. That is my final answer. I cannot figure out an evaluated answer because they didn't tell me what x equals. On letter B, same kind of thing. All in brackets mean they're multiplying. There's no exponent on the outside of brackets. So I multiply the coefficients. I get 18. And I add exponents on all of my a's. So I'm going to get 18, a exponent 12. That's as far as I can go there. Letter C, if I take a look, 30 and 45, that is going to give me a fraction. It's actually going to give me a decimal if I divide them. So if I take that one, because the number on top is smaller, what you do is you put it in your calculator and you math frac it. So you hit math, enter, enter, to make it into a lowest term fraction so that you know what the fraction will look like after. So 30 divided by 15, or 45, is going to give you 2/3. Because they both divide by 15. And then you're going to subtract your b's. When I subtract my b's, I get 14 subtracting 10. I get b exponent 4. It's positive. Whenever you answer one, it always goes on the top first. It's not going to go on the bottom. Even if that was a -4, he starts on the top when you solve it. And then I would put it into the bottom to become a positive, if it was originally negative. Okay? So your answer could also look like this. 2/3, b exponent 4. Okay, so you could have 2/3 written beside it like this, or you could have it with the 2 beside the b. Okay? If it's written as it beside it on the right-hand side here, you have to understand the b belongs with the 2. Okay? So sometimes it's going to get written like this, and the b belongs with the top one. All right, we take a look at letter D. Letter D, I've got same bases. I don't even see any multiply signs in there, but because they're sitting side by side, I know it means multiply. So now I'm going to take it, I'm going to add my exponents on my x's and add my exponents on my y's. I'm going to get x exponent 8, y exponent 12, and I can't go any further. With letter E, I get the same situation as letter C with a fraction. This 10 and the 4 will only divide and give me a decimal. So you math frac that, and you're going to get 5/2. That's the lowest terms for 10/4. Now we subtract our e's and subtract our f's. I get e to the 4 and f to the 10. And again, they're up there on top beside 5. On letter F, I've got a hidden 1 exponent on that 3. So now my outside 3 exponent multiplies to all the exponents inside. I will have 3 cubed, x exponent 6. And now I can also solve 3 cubed. 3 cubed is going to become 27. The x to exponent 6 comes down. So now my final answer is 27 x exponent 6. Letter G and H have x's on top and bottom. So we are going to simplify top, simplify bottom, and then subtract top to bottom. That's how we solve letter G. On top, when I add my exponents, I'm going to get x exponent 8. On the bottom, adding my exponents, don't forget I have a hidden 1 on the x. I'm going to have x exponent 3. Now my last property is dividing. Dividing means I subtract exponents. That's going to give me x exponent 5. I'm going to subtract the 8 and the 3. Okay, we're going to take a look at letter H. Letter H, we're going to simplify the bracket first because I have exponents outside the bracket, so they need to multiply inside the bracket. The bottom one, your coefficient with 2 has a hidden 1, don't forget that. So your 3 multiplies into your bracket as well. So on top you will have 16 x exponent 6, y exponent 10. On the bottom you have 2 cubed x exponent 6. Now 2 cubed is actually 8. So I can replace that with the number 8. So I actually have 8x exponent 6 on the bottom. Now my very last step is to simplify, which means take your large numbers, your coefficients, and actually divide them. Then take the ones with the same base and subtract their exponents. So 16 dividing by 8 is going to give me a coefficient of 2. x6 subtract x6 gives me x to the 0, which equals 1. So basically it disappears because 1 times 2 is just going to give me the 2. So when you see the same number on top and bottom, you can just cross it off. You don't even have to worry about it because it disappears. The next thing, I'm going to have my y by himself. I get y10. So your final answer will be 2 exponent y10. Or sorry, 2y exponent 10. Letter I, we have an outside exponent again that has to multiply to the inside exponent. So I'm going to multiply him in. And negative times a negative will turn my exponents into positives. So I'm going to have a exponent 6 on top of b exponent 15. We cannot combine those any further because they have different bases. We're done. If I take a look at j, the coefficients I can divide, and I'm going to get a 2. My a negative 5, my b negative 3 is still on the bottom. But I always want my answers in positive exponents, never negative showing. So that means that the a and the b being negative have to switch places to become positive. So when they switch places, their exponent goes with them. The 2 stays where he is. He has a hiding positive 1. He doesn't go anywhere else. He stays where he is on top. So my final answer will have my 2 on top. My b cubed now comes to the top and goes positive. And the a to the 5 now goes positive on the bottom because they switch places. If we take a look, we're going to convert now to radical and exponential form back and forth. This one's in exponential form, so I need to convert him to radical form. So I've got 5 timesing by x to the 4 over 7. Well, the one with the exponent that is a fraction, that is the part that gets changed to a radical. The one that doesn't have the exponent doesn't get changed to a radical. It becomes the coefficient. It stays outside in front of our radical. So now this is going to become 5 times my 7th root of x exponent 4. The 5 is outside in front of the root sign. The 7 on the bottom of the fraction becomes the index on the inside of the check mark part, and the 4 stays on top of the x as an exponent. The next 3 I convert back to fraction form. This guy, b is my base, 2 stays as the exponent. I put the index, the 3, as a fraction under my b. The index goes to the bottom. So I have b exponent 2/3. So the fraction on the b is 2/3. So this guy is going to look like 1 over a exponent 7. What is the radical or the index on this radical if I don't see an index? There's never an index of 1 for radicals. It's 2. The hiding one's always a 2. That's your square root, remember? So that's square root. So that means that I have a 7 over 2 on the bottom. Now, I want, this is exponential form, but it's in fraction form still. I want to find out, this was obviously flipped upside down, correct? He was flipped upside down because I have a 1 on top. He originally would have looked like this. A 7 over 2 over 1, but because I flipped him, he's negative. The exponent was negative. So remember, if I have negative exponents, I flip them to the other side and they become positive. So this one here originally started like this. Okay, either or would be correct. Letter D. Letter D is a little bit more challenging because we've got a coefficient, the number 2. The number 2 serves the same purpose as the 5 did over here. He's out front, so he's going to get attached to the variable with the exponent. So my 2 is my coefficient. My h is my base. The exponent is going to be 4 over 3. So 4 over 3 on my h. And exponents in fractions are usually in brackets. So this guy is going to be 2h to the 4/3. That's what he would look like. The next section is student practice. Please practice on your own and push play when you are finished for the answers. Okay, let's take these questions up. On the first one, I'm going to go through them, just write the answers. If you have a question you'd like me to explain it, please stop me so I can explain it to you. We're going to add the exponents on this one. So we're going to get b exponent 7. The next one, we're going to get x exponent 7. We have a hiding 1 there. Here we're going to get b exponent 11 by adding the exponents. Over here, multiplying exponents, I get 2 exponent 6, which solves down, and I get 64. The next question, I'm going to subtract my h's. I'm going to get h exponent 3. The next one is subtract. I'm going to get y exponent 6. Here I'm going to get s to the 6, t to the 6. Over here I've got 3 sets of these, which means I've got negative 4 cubed, x cubed, y cubed. Now I solve negative 4 cubed to give me negative 64, x cubed, y cubed. Now we're going to move on to I and j in the bottom of the page. Please check your answers. Hopefully you got them right. The next one I should have x to the 9 over y to the 9. Here I should have c squared over 4 squared. Solve the bottom. I'm going to get c squared over 16. Moving on to the next section. Any questions about that first section you'd like me to go through? Pretty good so far? Okay, on these ones, we're doing exactly what they tell us. We want positive exponents. So we're going to have b to the negative 7 over 1. I need to flip him to give me 1 over b to the positive 7. The next one, I'm going to have 6x squared dividing by 2x to the 7. Set it up as a division sentence so that you know exactly what it's doing in fraction form. So now I can actually divide my digits. I'm going to get 3x to the negative 5 when I subtract my exponents. This now must be put over 1, and the x must go to the bottom. The 3 stays on top because he has a positive hiding 1. We have 3 over x to the 5 as a final answer. Okay, the 3 does not move to the bottom. He's got a positive hiding 1 for an exponent. So he stays on top. Just the x moves down. Do you see where you made your errors? Hopefully. Okay, now on example 2, these all are negative exponents. One of the tricks with negative exponents, you can flip the inside first, and then the exponent on the outside becomes positive. So this is the same as saying d over c, now all cubed, which gives me d cubed over c cubed. Okay, you can flip it as a last step if you like as well. It doesn't matter which way you do it. They both get the same answer. This one I'll do the other way. I get x to the negative 3 over 4 to the negative 3. They will flip places. I'm going to get 4 cubed on top of x cubed. Now I solve my 4 cubed to get 64 over x cubed will be my final answer. Yes, it's not a negative because the base is not a negative. If the 4 was a negative, then it would be a negative 64. Okay, so it gets rid of the negative exponent when we actually flip the question. If I take a look at letter C, I'm going to have p to the negative 6 over r to the negative 12. Now they have to flip places and change places. I'm going to have R12 on top of P exponent 6. Any questions on those sections? So far, so good? Okay, rational exponents, we're going to do the same thing here. We want to write as an equivalent radical, it tells us. So my bottom number is always the index. That gives me a cube root of R exponent 1. Do I have to put that 1 there? No, you do not have to. I'm just showing you so you know where it goes. This guy here, first of all, you should flip him to become a positive exponent. So you're going to have 1 over V to the 3 seconds, which then becomes 1 over square root V cubed. The square root, that 2 becomes a square root. Okay, the 2 can hide in a square root, so that's why I'm not drawing it. Is it wrong if you draw the 2? It's not wrong, it just always hides. The letter C is done very similarly. It's over 1, and I have to flip it like I did with letter B on the V. So I got to flip this guy. He's going to become 1 over T to the 1/6. Now I can take that into a radical by going 1 over 6th root of T exponent 1. Do you have to show the 1 there? No, you don't. Letter D. Letter D, I have a negative base and a negative exponent. The negative base, when I flip it, still stays negative. The only thing that changes when you flip it is the actual exponent. He's the only thing that switches to positive. So this becomes 1 over negative Z to the positive 5/3. Now I can put the 5/3 into a radical. This is going to give me 1 over cube root of negative Z in brackets still to the 5th power. The Z is always in brackets because he has his negative sign. The negative doesn't go away because he belongs to the base. He's not an exponent. So when you flip it, it doesn't disappear.
If you don't put the brackets, is it wrong?
If you don't put the brackets, is it wrong? It started in brackets up here, so yes, you should keep it in brackets. If it was an even number here of 2, 4, or 6, it would matter, because if I did an odd number, it will always give me a negative answer. But if it's an even number exponent, when you solve it, that would give me a positive answer.
Okay.
So yes, keep the brackets.
Okay.
Letter E, solving letter E. The only thing over here that has the exponent is the letter T, which means the T is going to be in the radical form. The 5 will be out front, attached to the radical in front. So I'm going to have 5 times the 4th root of T cubed. And that's how we solve that one. Letter F is done differently than letter E because the 5 and the T are in brackets, which means they are the base together. So they will be underneath where this T cubed is. They go together this time. So on letter F, I'm going to get 4th root of 5T, and yes, they're in brackets, cubed. You could take them out of brackets if the 5 and the T both had cube sign. So I could simplify it further and go 4th root of 5 cubed T cubed, which can go even further. You can solve the 5 cubed, which many will. So this 5 cubed underneath here now, our final answer would look like 4th root of 125 T cubed. Now, which answer is correct? The final answer here is correct. You should solve that 5 cubed under the radical. If you don't, you probably lose a half mark if it's a written question. Any questions so far? No? Okay, last couple of examples. This one now wants us to put it in radical form and evaluate if possible. So this one here is going to go into a square root. So I have square root 25 all cubed. Now radical signs behave like brackets in BEDMAS, which means you solve underneath them first before you find the root of something. So this I need to solve underneath it. So I'm going to have the square root of 15,625. When you solve that, you'll get an answer of 125. So the full answer of this should give you 125. Okay, when you solve that, that's what this becomes. Letter B, our base is negative. So what we're going to have is the cube root of negative 8 squared. Negative 8, because it's in brackets, keeps its negative sign. So that means I have two negatives. He'll become positive. That is the same as saying the cube root of 64, which is 4. So the answer for B is 4. Any confusion so far? Pretty good? Okay, we're going to move on to letter C. Letter C, we have a negative exponent, so we've got to flip him first and then put him into radical form. So let's do letter C. So I'm going to put C over 1 and flip him. So I'm going to have 1 over 16 to the positive 3 over 4. That means I'm going to take 1 over the 4th root of 16 cubed. Now I find 16 cubed, which is 4096. So now this becomes 1 over the 4th root of 4096. We have to solve under the radical, so you have to actually go 16 cubed. That'll give you 4096. Now we can take the 4th root of this. Taking the 4th root of that, I'm going to get 8. So that means my answer is 1 over 8, or 1/8. So the answer to C is 1/8. Letter D has brackets. You must solve inside the brackets first. So for letter D, we are going to have 9 plus 16 in brackets solving first. Continue to solve them. I've got 25 now to the 1/2. To the 1/2 means I'm going to take root 25 to the hidden exponent 1. Everybody knows that root 25 equals 5. So the answer for D is 5. Now remember, radicals can have positive answers or negative answers. So really, my answer for this could be positive or negative 5, correct? I could have 5 or negative 5. Okay, for a square root. Moving on to number 3. We now want to put them into positive exponents or just change them to exponential form. When I change them to exponential form, I have to take a look at the exponent on the variable under the radical. It looks like there's nothing, but there's a hiding 1 on my x. So that means I've actually got x to the 1, and my 2 comes from the index of a radical. That index in there is a square root. It's a 2. He's a positive exponent, so I'm done. I can't simplify any farther. This one becomes b. 5 stays on top. 3 goes to the bottom of our fraction. We are done with letter B. Letter C, we also want to leave it in positive exponents, so I'm going to leave it in a fraction like that. I take this guy out of brackets, the a cubed, or out of the radical, and he becomes a to the positive 3 over 2. And again, that's a positive exponent. I'm not going to flip them to become negative. They wanted positive exponents. On this one here, the 4 is going to multiply and be the coefficient in front of my variable. So I'm going to have h to the 6 over 3, and the 4 is in front of it. Well, what do you notice? 6 over 3 is going to reduce and give you a 2. So do you reduce it? Yes, you do. So this is going to give you 4h squared, your final answer. That concludes our intro lesson 1.0.